Assalamualaikum warahmatullahi wabarakatuh to our honorable examiners Dr. Azlan bin Ismail and Dr. Kamal bin Muhammad Shah. I am the representative for Infectionist Group E1 under supervisor Dr. Muhammad Kamal bin Muhammad Shah. My name is Nur Aina Awani binti Muhammad, matrix number PK181106162. This group consists of 4 members which lead by Abdul Qidir Ahmadul, also hold the position of CAD engineers, followed by Asri bin Mataha as the secretary and material costing manager, and members Liana Rashida binti Muhammad Ramzi as the design and analysis engineer, and myself as manufacturing engineer. Today, we would like to present our group project for Integrated Development Project IDP titled Design and Development Simulation of Impact Test Machine with a disposal compartment for fiber composite material. So firstly, this is our group organization chart, which consists of our position and responsibility in this project. For examiners further information, the development of this project was purely depends on our technical expertise gained from several courses such as Dynamics, Electrical, Machine and Power, Mechanical Design 1, Computer-Aided Design, Statics and Strength of Material, also Engineering Material. First and foremost, the background of this project is actually related to the main properties of building and construction material, which includes the mechanical, physical, chemical and technology. As we know that in the manufacturing and construction sector, material selection is one of the important factors that an engineer must pay attention to. In addition, the physical and mechanical properties of a material need to be precise to ensure that the material is qualified enough to be used in certain construction, building and manufacturing. This part can be determined as a step to overcome the failure and damage that might happen if it being ignored by the engineer. In general, a good material for construction needs to have a great physical and mechanical properties such as high in strength and permeability, has high gross-capacity features, high water resistant and sometimes also be soundproof. Moreover, the use of composite material is quite popular among engineers as the replacement material that can be used in construction and manufacturing due to some factors such as low cost and having a lot of benefits in its properties, either physical or mechanical. For instance, fiber composite. This composite is widely used in many industries such as in construction, automotive and also aerospace. Fiber composite consists of many types and names. For example, Tonel Mat BMA, Sorted Panex 33 and many more. This happens due to the fiber have tons of advantages such as high strength, lightweight, low density, high stiffness and many more. So aside from that, let's go more deeper into our mission for this project, which is impact test. In common, impact test is a technique that has been used by engineers to determine the properties of the material. This technique has been used by many methods in terms to determine the behavior of the material to the shock landing, which act as the force on the material. Impact test is one of the famous methods that currently being used in all over the nation for determining the material properties, and it not only used for composite material but also for other material. Furthermore, impact test includes many methods such as Charpy, Izoid, Dropweight and many more. Next slide is illustrating the flowchart of our flow work from the beginning of the project until the final step of the project, which is documentation. In the first phase, group members having a meeting to brainstorming the idea of the project as a step of problem identification. From that, the background research has been done to determine the existing research for our project, which act as our guideline to go through our project. Furthermore, from the literature review, the design modeling for conceptual drawing and selection have been done, continued by material selection and CAD drawing in terms of 3D modeling. Later, the design simulation was carried out and the analysis was observed. This step was repeated for countless times as the result is not as what we want, so we undergo troubleshooting to fix the problem until it meets our expectation. After satisfying with the design and so on, the final analysis was done and discussion has been made for overall process. Lastly, all the results have been documented and submitted to our honorable examiner. In other hand, this project consists of 3 objectives. The main objective is to design and develop a simulation of impact test with disposal compartment machine for fiber composite material. Secondly, to identify the amount of energy absorbed by the material during the fracture, and lastly, to stimulate the testing waste of the sample into a disposal texture. From buckling and yielding analysis for crusher, the buckling factor of safety can be determined. This analysis needs to be done as to determine the factor of safety against the current applied loads. As we know that buckling effect is often leads to bad results toward the model, which happen when the axial load column loses its stability. In other words, the column start to having an unstable configuration equilibrium. Thus, by utilizing a high factor of safety is one of the efficient way for buckling loads. Essentially, the factor of safety can be used is more than 3. Furthermore, the buckling analysis for a project is calculated using these equations. Since the material chosen are stainless steel, the mechanical properties of this material are consisting of Young modulus, which is 190 megapascal, and yield strength, which is 206.807 megapascal. Based on the calculation, if the critical slenderness CC is more than the value of critical tangential C, thus the Johnson equation is used to calculate the critical loads on that part. However, if the calculation of value critical slenderness CC is lower than value of critical tangential C, hence the Euler equation will be used to determine the critical loads on that part. The calculation was done on frame-based material supporter, material base of the machine, and also the impactor rod. And from the calculation, the value of critical tangential for frame-based, material-based supporter and impactor rod is higher than the critical slenderness. Thus, Euler equation is used to determine the critical loads of the column geometry of the machine. However, the calculation for material-based result in higher value of the critical slenderness. Therefore, Johnson equation is applied to determine the critical loads on that part. Moreover, from the equation F equal to ma, where m is mass and a is the acceleration of gravity, which is 9.8 meter per second square, we can determine how much the maximum force on the impactor can be used to withstand the force before it collapses. Therefore, from the calculation, we can conclude that the rod can withstand the force not more than 30 Newton, which means if the force applied more than 30 Newton, the impactor rod will collapse immediately.